Hello class, this is Mr. McAllen, and I promised you that I would take you through a couple quick examples of the difference quotient that we did in class today. This is basically just a repeat of the lesson we did in class, and I wanted to give you an opportunity to re-examine what we did in class today in case there's anything that you may have missed. So here we are, we're discussing the difference quotient, and the first thing we did was we wanted to make sure that you knew how to FOIL or remembered how to FOIL. So I'm just going to rewrite what we did for FOILing this binomial, and when we FOIL this, you get x squared plus not just x squared plus a squared, but x squared plus ax from the outer plus ax from the inner plus a squared, and your final result is x squared plus 2ax plus a squared. After we did that work, we discussed briefly, and I'm going to leave this here and you can pause the video whenever you like, of course. We discussed what a difference quotient was, and a difference quotient is basically a formula to find the average rate of change. So if we look at this curved equation, any point we choose, if we draw a line between the 2 points, that's called a secant line. And if we find the slope of that secant line, that, as we've done in class, will represent the average rate of change of the function. And the average rate of change, since we've been working with function notation, is equal to, in terms of functions, f of x plus h, that's this value at the top, minus f of x, all over the difference in the x coordinates, which is x plus h minus x, which will always be equal to, in the denominator, h. And h represents the difference between the starting x value and the ending x value. So in the numerator we'll have function notation, which is the function at a point at the location x plus h minus the function at x. So now we're going to apply that difference quotient to a simple linear equation. And I just want to remind you guys that this is a linear equation that has a y-intercept of 2 and a slope of 3. And that would be 3x plus 2. Now we all know that the slope of this equation is 3. So when we do the difference quotient, we should end up getting the difference quotient equal to 3. So here we go. We're going to start out. I'm just going to write out the general formula. And now we did this exercise in class where we were just trying out a couple things where we said, what's f of x? And everybody said 3x plus 2. And I said, what's f of a? And everybody said 3a plus 2. And they said, what's f of Dan? And everybody said 3 Dan plus 2. And then I said, what's f of x plus h? And finally everyone came around and they were like 3 x plus h plus 2. And that's the important ingredient we need to be able to get, so that when we assemble our difference quotient, we can plug in the correct quantity and then solve for it. So here we have the difference quotient is equal to, I've made my correct substitutions for x plus h and f of x, and when I distribute, and divide by h, one of the amazing things that happens is, with the difference quotient when you do the algebra right, that terms drop out and you're left with something reasonable to simplify, and 3h divided by h is going to be 3. So the difference quotient for this formula, which is a line, which means the average rate of change. Now, anybody who studies pre-calc, we should all know that any linear equation, the average rate of change of that line is the slope. So there's no mystery why the slope is the same value as the difference quotient. In the next video, I'll be working with showing you how to do the difference quotient on this quadratic formula. So if you enjoy this video and you want to see how to do the more complicated function, tune into that one. So hope this helps, and we'll talk to you soon.